Okay, so now we're going to talk about Cramer's rule. What Cramer's rule allows us to do is figure out what, so for instance on 13, they're asking you to solve the system of equations, and we can technically do this by using elimination and substitution, but we're going to actually use Cramer's rule to do this. And we're just only going to use determinants. So what this tells us is if we take the determinant of the coefficient matrix, which would be the 12, 3, -3, and 2. Okay, this is, so I'm looking at 13. That's just this stuff. This is the coefficient matrix. This is 12 times 3, -3, which is -36, minus 3 times 2, which is which is 6. So this is -42. Okay, so that value is what we're going to divide by in the end. But what Cramer's rule says is if we take these two solutions and plug them in for the x coefficients, so we've got 15, 13 instead of 12 and 2, and we've got 3 and -3, then this is going to equal -45 minus 39, which I think is -84. I hope. Yeah, hold on. 9 and 4 is, yeah. Yeah, this is good. Okay, so -84, so we've got x is equal to -84 over -42, which means x is equal to 2. So we've got an x value for that solution. Now we're going to do the same thing, but we're going to plug, instead of plugging them into y, I'm looking over here, we're going to plug them in for, I'm sorry, instead of plugging them in for x, we're going to plug them in for y. This is 12 and 2, and 15 and 13 now. 12 and 2 is going to be, or 12 and 13 is 144 plus 12. 156 minus 30, which is 126, I think. Wait, 144 plus 12. Yeah. Yeah, that's good. 144 plus 12. Okay. So 126. And then divide by -42, which is going to be -3. So 2, -3 should be the solution to that system. So let's try it. 2 times 12, so 12 times 2. I'm just plugging these into this original equation. 12 times 2 plus 3 times -3. 24 minus 9 is equal to 15, which is what they got. That's good. And 2 times 2 minus 3 times -3. 4 minus, no, plus 9, which is equal to 13. And so as you can see, we got the correct answer, and we did it by using this thing called Cramer's rule. So that went kind of quickly. Where it may be helpful is with 3x3s, but the only thing is with 3x3s, these are kind of long. So it might not be as fast just to do it this way. You might want to just still do it the way that we originally did it. So I'll do an example of that right now. So we're going to do 31. And I'm going to do the coefficient matrix. We have 4, -5, -6, 1, -2, -5, 2, -1, and 0. Okay, so I'm going to use the trick I showed in the last video at the end. So I'm going to write the first two columns, 4, 1, 2, -5, -2, -1. And we go this way. So that's 4 times, so what I'm going to do is I'm going to do 4 times -2 times 0, which is 0. So I'm just going to write that. -5, so I'm doing these ones now. We're multiplying those. -5. -5 is 25, so plus 25 times 250. Oops, so that's 50. And then times these ones, this is -6, 1, and -1. So that's going to be positive 6. So 56. And then we're going to go backwards. So we're going to do these ones, and these ones. So we have minus 5 times 1, negative 5 times 1 times 0 is 0. 4 times negative 5 times negative 1, that's plus 20. And negative 6 times 2 times, negative 6 times negative 2 is negative 12, or positive 12, times 2 is 24, so plus 24. And so this is 20 plus 24 is 44. And so I think this is 12. Okay, so that's the bottom. So if we want x, y, z, it's going to equal something over 12 over 12 over 12. Okay. And now let's figure out what x, y, and z are. We're going to plug the solutions in for the x column and then solve it. So we have negative 1, negative 12, 7. And then we have negative 5, negative 2, negative 1, negative 6, negative 5, and 0. Determinant. And we are going to write them again. Negative 1, negative 12, 7, negative 5, negative 2, and 0. Oh, I don't need that line. So we go this way. That's 0. 25 times 7. 25 7 quarters is $1.75. So 175. And then, oops, this one should not be 0. I wrote that wrong. This should be negative 1. These two, 72 times negative 1 minus 72. So this is going to be 103. Minus, we're going backwards now. We're doing these ones. 0. So this one going this way is 0. These ones, that's negative, 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 that's negative. 5 times 1 is 5. Negative times negative is 12 and 7. What is this? 12, positive 12 and 7. Yeah, it's plus 72. So this is going to be 103 minus, this is 72, 67. 103 minus 67 is 13, that's 6, that's 936. So we replace the x's. This is 36. So 36 divided by 12 is going to work. That's going to be 3. We'll get that in a minute. Okay, so we've done x. Now we're going to do y. So we're going to plug those same values, negative 1. Sorry, not those into that column. We're going to plug them into the middle column. So you have 412, negative 1, negative 12, and 7. And negative 6, negative 5, 0. Okay, so we're going to go ahead and 412, negative 1, negative 12, and 7 goes 0. That's going to be 5, 10, plus 10, minus 42 is negative 32. Minus parentheses this way, that's 0. These 3, sorry, I did these 3, that's 0. These 3 is going to be negative 20 times 7, that's negative 140. And positive 72, 144. Which is negative 32 minus 4, negative 36, which is negative 36 up here, which is 3. So that one's good. And then finally we're going to do z. So we're going to do this one more time for the z column. So as you can see, this doesn't really save us that much time. I mean, even if you were super quick, it wouldn't. But we have 4, 1, 2, negative 5, negative 2, negative 1. And replace the column negative 1, negative 12, and 7. This is the solution column now, z. We rewrite 1, 4, 1, 2, negative 5, negative 2, negative 1. Multiply this way. Oops. Not too much this way. Negative 8 times 7 is negative 56. 5 times 12 times 2 is positive 60 times 2, 120. And then negative is positive 1. Oh man, I don't know what this is. This is 121 minus 56. That's 1, that's 1, that's 5, 0, 11 minus 5 is 6, 65. This is 65 minus, okay, we're going to go backwards now. I'm going to do these 3. That's negative 35, oops, 35. Negative and negative is positive times positive is positive, so plus 12 times 1. Oh, 12 times 1 times 4. 12 times 1 is 12, times 4 is 48. And then times these 3, that's negative and negative, positive. 2 times 2 is 4, positive 4. And so this is 52 minus 35, which is, this is 4, 7, 1765 minus 17. I think it's 48, right? This is going to be 8. Yeah. 5. Oops. Yeah, so this is 48. And so we get 48 up here. And for the grand finale, I'll do the rainbow color thing. We've got 36 divided by 12, that's 3. Negative 36 divided by 12, that's negative 3. And 48 divided by 12, that is 4. So your solution to this system is this. I believe that's right because it'll be pretty hard to get nice numbers with this, considering the fact that the determinant can be any number, and then dividing the other 3 numbers have to be divisible by it. So I think it's pretty rare to get, if you're going to get whole numbers here. I mean, we could have got anything. We could have had 17 over 36, which wouldn't have been nice. And so I think that it's likely that if you get whole numbers, it is good. Thank you guys for watching. We're going to do inverses next.